Okay, guys, welcome back to FG.1 Notes Part 2 today. We're going to go ahead and finish these FG.1 notes. It's not going to take very long, just one real concept that we need to cover today. And that concept is what we call the average rate of change. Average rate of change. This is something that you saw back in Algebra 1 when you were dealing with lines. You probably called it slope at that point in time. Slope essentially is average rate of change. So we are going to take average rate of change beyond slope of lines, just lines anyway. Average rate of change is we're going to define it as the average amount that a function increases or decreases over a given interval. So this could be a line where you talk about slope, or it could be a function that looks something like that. And we would look at the average rate of change maybe over 2 points on that function. Okay, so this could be very basic, but also a little more complicated. Basically, how you found slope in Algebra 1 is what we're going to use to find the average rate of change. So we're going to show you some new notation. This is delta y over delta x. Delta in the math world, it's a triangle, but delta in the math world means change in. So this is to find average rate of change. We find it by change in the y's over change in the x's. And how do you do change in y over change in x? Well, you do y2 minus y1. Technically, it doesn't have to be 2 followed by 1, but this is the notation you guys have seen, over x2 minus x1. So this formula essentially is going to find, you use to find slope in Algebra 1, but you're going to use it to find average rate of change for any interval. Let's go ahead and take a look at some examples. Problem 6. In problem 6, it says a cardboard box manufacturing company is building boxes with length represented by x plus 1, width by 5 minus x, and height by x minus 1. The volume of the box is modeled by the function below. So we don't need to know the function necessarily to answer the question. It says, over which interval is the volume of the box changing at the fastest rate? So notice this notation with brackets here. This is an interval. It's talking about x values. So we need to find out the average rate of change for each one of these to figure out what the fastest average rate of change is going to be. So let's just take a look at number 1. I'm going to show my work down here. Number 1 is dealing with this point 1 where x is 1, so the point 1, 0, and where x is 2, notice these lines are 2 at a time on the y-axis, so this would be 2, 9. So if we want the average rate of change for this option number 1, this interval number 1, we want to do the change in y over the change in x, which is going to be 9 minus 0, y minus y, so 9 minus 0, over x minus x, 2 minus 1. This would simplify down to 9 over 1, which is just 9. So the average rate of change for interval 1 between the x value of 1 and the x value of 2 is 9. Let's find the average rate of change for the second interval. So we're still using this 0.10 here, but now we're going to go to 3.5, and let's approximate this a little bit. Let's say that right there is about 3.5. So this is 3.5 or 3.5, 17. So now if I want the average rate of change for 3.517, I need change in y over change in x, which would be 17 minus 0 over 3.5 minus 1. This would be 17 over 2.5. Now let's go ahead and let's approximate this so that we can better compare this to 9. We should know that this is less because 17 divided by 2 is going to be less than 9, but in this case, we now know that this average rate of change is about 6.8. So every time we move over 1, we're moving up about 6.8 units. Where in the first example, when we moved over 1, we were moving up 9 units. So the interval number 1 definitely has a higher average rate of change. Let's take a look at interval number 3. So we're still using 1, 1, 0. Now we're using 5, 5, 0. This one you may not actually have to do any math for. So we can see that the graph does go up and does go down. But as I compare here, I do change in y, y minus y would be 0 minus 0 over change in x, 5 minus 1. This would give me 0 over 4, which is 0. The average rate of change for the interval number 3, even though we see that it goes up and then goes down, on average, it's not moving. So we had a positive rate of change here, followed by a negative rate of change. So average across that interval, the average rate of change is 0. Go ahead and pause the video and see if you can find the average rate of change for the fourth interval. The fourth interval, hopefully you found that. The fourth interval is using point 0, negative 5, to point 3.517. So again, change in y over change in x. This would be 17 minus negative 5 over 3.5 minus 0. Now, you may have done this backwards in comparison to how I did. You may have done negative 5 minus 17 on top in the numerator. If you would have done that, that's okay. You would have just done 0 minus 3.5 in the denominator. When I simplify, I get 22 over 3.5. You would have had 22 over negative 3.5, which would come out to the same answer. So we can simplify this expression to just double check and make sure that this is what that value is going to be. And this is approximately, let's go ahead and just round to 1 decimal for this point. It's good enough, 6.3. So which of these intervals have the highest rate of change? Problem number 1. And we can find that again by taking the change in y's and dividing by the change in x's. Last question in the notes. Problem number 7. So the table to the right shows the number of hours of daylight on the first day of each month in Rochester, New York. Given the data, what is the average rate of change in hours of daylight per month from January 1st to April 1st? And then we're going to interpret the meeting. So let's first find the average rate of change, which is, again, change in y over change in x. In this case, x and y, remember back to Algebra 1, independent and dependent variables. The independent variable here is going to be month. Month is going to change regardless. The hours of daylight rely on what month it is. So that's our dependent variable. So basically the month column is x, daylight is y. Now we need to go ahead and attribute some numbers to these. The x column, we could say January is 1, February is 2, so on, so forth. April would be 4. If you said January is 0, April would be 3 in your x column, and that's okay. You'll still come up with the same answer. So now, change in y over change in x. So I'm going to go ahead and do 13.9, the average daylight for April, minus 9.4, the average hours of daylight for January 1st, over 4 minus 1. As I simplify that, I get 4.5 over 3, and 4.5 over 3 is 1.5. So the average rate of change is 1.5. Well, what does this mean in the context? Remember average rate of change, the definition, the average amount that a function increases or decreases over a given interval. So if we wanted a full explanation, we could write out a full explanation or put this into context. So let me change the color of that font. From January 1st to April 1st, on average, daylight increases because it's positive, increases 1.5 hours per day. Or sorry, on average, daylight increases 1.5 hours per month. So each month, the average increase is 1.5 hours. We could see that between January and February, that's 1.2. And then from February to March, it's 2.3. And then from March to April, it's 2. But on average, they're going to fluctuate 1.5 hours every month. And this is average rate of change. With that, we have finished the FG.1 notes. So The next time we come into class, you'll have the opportunity to ask some questions. We'll continue to work on homework, shore up any misconceptions that we have, and then we will be prepared for our first quiz in unit number 2. Thank you guys for tuning in, and I'll see you soon.